Morning, everybody. If you'll turn in your books to page 476, we're going to learn about symbols for sets, and they're going to ask us to graph things using what's called set builder notation. Instead of just telling us graph the solution to y is greater than x plus 1 and y is greater than or equal to 3x plus 5, they're going to word it differently and put it in set notation. So the first thing that we need to look at is when they say natural or counting numbers, that's n equals, and when we count, we start with 1. And that's going to be, they're going to represent that with an n. Whole numbers, they're going to represent with a w. And remember, the difference between whole numbers and natural numbers is that whole numbers include 0. And then integers, they let that be a z because I stands for the square root of -1, so we don't typically use I for anything else. But integers then, dot, 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 -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. Okay, so there's integers. Another one that we have is q. They let q represent all rational numbers. Remember, a rational number is any number that can be written as a fraction of two integers. P, which we don't very often use because we very seldom use irrational numbers, but P is the set of irrationals. R, like usual, is the set of real numbers. And C is the set of complex numbers. All right, so make sure that you familiarize yourself with especially this one, this one, this one, and always know this one right here, the real numbers. Okay, so look on page 477. Let me show you what I'm talking about. The problem says to graph this. Okay, it's in braces. This x comma y tells me that I'm graphing this on a coordinate system. In other words, like this, x and y. Okay, that's what it tells me. Such that x and y are real numbers. That's what the r is for. And it's r squared, but it's not really r squared. It just tells me that we have two dimensions, x and y. That's why this 2 is here. Okay, such that y is greater than x plus 2 and y is less than -x. Close the brace. So all of that, that's called set builder notation. You won't ever have a problem graphing on the xy coordinate system that won't have reals as their domain. This is the domain when it's written in this format. Can you imagine having to go in and put dots on the corners of all your graphs as the domain was integers? That would be a nightmare. Okay, so we're not going to do that. All right. So the domain for when you're graphing on an x and y coordinate system will always be this reals squared to tell you it's two dimensions. Well, here's the two lines we're going to graph. So it's already in slope-intercept form, so I put a point on 2. My slope is 1, so up 1 over 1. It says greater than, so I know that it's a dotted line, like that. And y is greater than x plus 2. Do I think that's going to be above the line or below the line? For greater than, I think it should be above, correct? All right, now we graph this line. If there's no number here, remember it goes through the origin. It goes through 0. It's the same thing as saying y is less than -x plus 0. And then we have a -1 slope, so down 1 over 1, and it's also dotted. Okay, so those two lines intersect right there. Okay, and then this one says y is less than, not greater than, but less than. So here's my line. Which side do I think is going to be less than that? Up here or over here? Less than is probably over here, isn't it? So now we've got above this line and on this side of this line, so it should be in this region, shouldn't it? That's where we expect it to be. So what do you have to do in order to shade it there? You have to pick a checkpoint in that region. So I'm just going to select this point right here, which would be 1, 2, 3, 4. That's negative 4, 0. And if it works for negative 4, 0, then I know I have the right region because every point in that region will work if it'll work for that one. So I'm going back to the original equations and I'm going to plug in for y 0 and for x negative 4. So 0 greater than minus 4 plus 2. Is 0 greater than negative 2? Yes. And plug it into this equation. 0 less than minus a minus 4, or 0 less than 4. Is that true? Yes. So yes, this region does work. So we shade this region. All right? Okay, so I want to do, let's see, one of these problems with you. Let's look at number 16 in your homework. 16 says set A is x is an element of z. What was z? Integers, such that x plus 1 is greater than 1. All right, so we know we can only have dots. This isn't z squared, so it's not an xy coordinate system. It doesn't say x and y. So I'm going to take this down here and I'm going to solve it. So x is greater than 0. So I have my number line. And I'll put 0, 1, 2, 3, 4, 5. Domain is integers. That's what z is. So greater than 0, do I include 0? No, 0 is not greater than 0. We go to the next integer greater than that, which would be 1, 2. How many dots do I have to put on the graph to indicate this pattern? 3, right? And then I can draw the arrow because it just keeps on going. All of those integers are greater than 0. Okay, that's it for lesson 117. I'll see